Today we're talking about real-time analytics for real-time decisions. Pretty exciting component of the Plixer platform, and I think we'll have some good discussion around it. My name is Adam Howarth. I work as a data scientist here at Plixer. I've worked on our probe platforms and quite a few of the different analytics solutions we have that will be relevant to what we're talking about today. Joined by Niels, who's in charge of our customer success department. Niels, if you want to introduce yourself.
Yeah, thanks, Adam. I'm Niels. I've been with Plixer for about 10 years, and we're excited to explore strategies that IT leaders and IT end users can use to optimize their networks, reduce downtime, and ensure business continuity. It sounds like, Adam, from our discussion, this webinar is all about actionable analytics, insights, and techniques to address the complexities of today's IT environment.
So just from a high level, what we're going to go over today, the role of insights in modern network operations, achieving total network observability, tailored insights for unique business needs, and we'll go over a couple of real world use cases, some kind of rough anecdotes of things we've run into in real life working with different environments.
So today's networks, guys, are really more dynamic than ever, right? Hybrid clouds, multi-cloud architectures, SD-WAN, remote work setups create an unprecedented scale of complexity.
So as kind of these input domains for network observation data have changed and morphed, making sure you have a total view of everything and really no blind spots becomes more difficult as the multi-vendor, multi-solution, multi-location complexity of a network increases. So really what we're focused around at Plixer is joining data sources from across your entire network in a single place where analytics can be run against them, kind of in a flat input domain. So really the major advantage to bringing all of the data into one place is real-time decisions can be made from input from several different things, right? So if you're being attacked or having some sort of performance problem that can be attributed to, a multi, kind of input component problem, we have a single place where all of the data is being considered and collected at an extremely high volume. So this helps us navigate through to what a root cause of a problem might be and ultimately kind of optimize the workflow of finding those things by preemptively running analytics against all of the data, again, joined in that single platform.
Yeah, and I mean, Adam, consider this, right? I think I saw the stat recently, which is that IT leaders like CIOs often report spending something like 40% of their budget on reactive network fixes, right? I mean, just imagine reallocating those resources to strategic initiatives instead.
Yeah, right. So starting a problem once someone's reported it versus having some sort of insight into what's going on actively on the network and be able to signal off of that as it's occurring. So observability isn't just about seeing what's happening, it's about understanding why. So just from a high level, there's lots of different technologies that will be involved and lots of different reasons why various performance problems might be occurring in different places. So again, having a platform that can collect huge volumes of data and normalize it so it can be processed and considered together for various detection analytics or performance detection analytics is going to be really a necessity as networks continue to grow and change in their topology.
Yeah, context, more context.
Yeah. So really, it seems kind of simple at first, just collecting network observation data. But then when you start to really get into the details of it, it's often formatted differently. It comes out under different, what's called an IP fix information element. So different vendors will call things different things. So really a main focus of our platform is, again, unifying all in the same place and also being able to normalize those different definitions so you can compare apples to oranges when it's really talking about the same security analytic. Pulling all of those things together allows us to report on those things, create visuals that can be kind of the single pane of glass that's maybe, quite often the Plixer platform ends up on a wall in a NOC or a SOC with some very high level analytics being displayed on dashboards that ultimately can be accessed from a user session, and then you can drill in and look at the source data. And then ultimately, having all of our analytic components and now with FlowPro, our network intrusion detection, kind of deterministic analytics running, the network is going to generate events and push them out onto the Plixer platform kind of as they're happening in real time. Again, back to the kind of the headline of this whole thing, as they're actually occurring, so that additional delay of a user having to feel the impact kind of is reduced in that case, right? Like you can create the ticket when the network is telling you it's happening versus when the network has caused an inconvenience already and then forced a user to generate the issue.
Right. It's the difference between resolving the problem before it becomes a real problem versus waiting for someone to call you and say, hey, O365 is dragging for us.
Exactly. And honestly, once the users felt it, kind of, it's kind of a mission failure already. I mean, the whole goal is to to really stop these things before it can get there. And using the network as your sensor is really kind of going to be the fastest way to do that. So predictive analytics really, for those reasons, transform network management from reactive to proactive, because as we watch the real-time feeds of data and detect these anomalies, and whether it's against security or performance, it really kind of depends on what the mission is. You're able to act on these things early. So between our forecasting engine or machine learning engine that's going to actively review the behavior of things that's happening on the network, having the ability to see when those things are occurring and then even drill back into historical data. The other major benefit is while we collect a huge volume of data and do our best to reduce it down to kind of a handful of actionable events, we do keep all of that very high volume data. So once something has been identified as actively happening from a real-time stream, it's very easy to go back and see, has this been happening all along? And then all of a sudden maybe that lines some things up where issues that were happening in the past suddenly make a lot more sense with kind of that current context.
Yeah, I think when I think of Plixer, root cause analysis is really our like bread and butter, and it's really great to see us move more and more into sort of the predictive analytics space. I think two great examples come to mind, both from the retail sector and both around holiday time. So one was, they were using predictive analytics to anticipate traffic spikes during Black Friday. And by, effectively anticipating this with Plixer, they were able to reallocate bandwidth in advance, avoid slowdowns, and ensure a seamless shopping experience and record sales. And then the other one is a bit more, that root cause analysis. I'm actually actively working right now with a customer who is in the process of deploying sort of handheld point of sale system and leveraging us, right, to ensure optimal performance and quality of service as those devices are used throughout the store.
Yeah, in a previous life, I ran a medium to large size retail network, and I wish I had tools like this because most of the time, by the time, we knew there was a problem, it was because a point of sale was trying to run a credit card transaction, and before you know it, kind of that PCI controlled space of the network was where all the congestion was happening, and you really, again, don't find out about it until it's already impacted the customer experience. Again, moving into predictive analytics is just a way of trying to get ourselves a little bit ahead of when it's actually going to be felt by the end user.
That's right.
So again, same kind of high level things we talked about previously. It's all about being able to take those examples and aggregate them down to make them reportable and ultimately pivot off of some sort of detection analytic that has already identified the problem and then just provide you with the source data so you know kind of where and when and why it's coming.
Look, I mean, when I think about, Scrutinizer, I think one of the things that is great is that by nature of how the platform is designed, we really recognize that every organization operates with its own unique sets of priorities, challenges, and goals, right? And a one-size-fits-all approach to network management just doesn't work anymore in today's, mixed vendor and highly dynamic IT environments, which is why I think tailoring insights to align with a customer's or your specific business needs is just so incredibly important.
Yeah, and just kind of it's not like the most glamorous point, but it really kind of turns out to be one of the most powerful ones, at least in the paradigm of how we are doing network monitoring and detection, is again the idea that multi-vendors environments will call the exact same metric different things, and they'll have different definitions. And unless your platform knows how to kind of decode those things and integrate them with analytics from other vendors, it makes it almost impossible to compare the output from one device to another, even if they're serving the same role in the network. And this is really just a benefit of Plixer has effectively existed longer than IPFix has, working in NetFlow v5, v9. So as the years have gone by, we've had opportunities to work with essentially all of the major networking vendors to make sure that we know how to decode and allocate the intent behind all of the different information elements. So Plixer One interactive dashboards are really a super powerful change to how the mass collection of network observation data can be performed. So if you think about highly vendor integrated systems, they can provide you insights into basically everything that you're running that is that specific vendor's technology. But then all of a sudden you end up with different silos between your visibility per solution. And then you now have to kind of pull a report somewhere or review an alert from somewhere and then correlate it with an alert from the other platform's kind of, data visualization or data retrieval interface. By joining all of these things together, we can produce really high level visuals, in this case, like things like network maps that show real-time link status, various traffic summaries, various application usage, network latency performance metrics, things like that. They can all be joined into single views. And then again, you can drill into any of these views effectively in on the Plixer platform, you can build report objects that are combinations of filters and input devices. And those report objects can then just be used as a data source for all of the visualization in the platform, as well as accessible through API calls. So if there's any sort of scripting or side visualization that maybe you've been building other tools into, maybe you have cross-functional, other areas of the business have data that you can integrate into the network data. Think about our retail example. If you actually have statistics about what is going through the POS system, and it can be aligned with your network performance data. We have API interfaces where you can integrate that all into the same place. And now you have this kind of seamless view of not only seeing all of the network observation side of what is happening in that retail segment, but as well as the actual context of what they're doing on top of it. So really making the data easily accessible is a major point of the platform. So we do it natively through dashboards, so it's ready to go right out of the box for you. But it is all accessible and extendable through a pretty easy to use API as well.
Yeah, and as someone who spends, vast majority of my time with customers, I can tell you that, this ability to fine-tune observability through our dashboards, really helps reduce, cognitive load on engineers, right? It means people are not getting as overwhelmed with irrelevant data or spending time sifting through like really unnecessary alerts. Definitely some tuning, right? There always is, but at the end of the day, what it means, instead, your team can zero in on actual actionable insights that drive better outcomes and make faster and much more informed decisions.
For sure. And just as a side on all this, as we're kind of moving into this landscape of M-assisted and AI-assisted workflows as well, the volume of flow data that is coming into the Plixer platform is far too verbose and repetitive in many cases, where it's the same host talking to each other, that it's really not a medium that can be applied into an LLM system, right? So by taking that huge volume of data and consolidating it down to either these type of summary views or just working off of the events that the predictive analytics stack has detected for you, it actually makes it a subset of events that's small enough that you now can pivot into some of these newer AI type workflows and have it assist you with remediation and things like that. So it's a very new field, but this flow is going to be a very interesting application in that space just because the volume of the input data is so high that something needs to process it in between to kind of augment that workflow. And the Plixer platform is kind of built for doing exactly that already for knock and stock workers. And I think people will find as you integrate it into LLM assisted workflows that this is really the best way of transferring your current network state into the context of that.
Yeah, it
that
condenses
LLM.
down and makes it more actionable, right?
Right. It's the same benefit that's helping the average knock and sock worker actually deal with some manageable volume of network
Yeah.
events is going to be the same type of summarization that's going to help you get some, better insights out of, really whatever kind of cognitive process or LLM starts to get integrated into workflows.
Yeah. Cool. Let's talk about some real world scenarios, Adam.
Awesome. So for the first kind of anecdote, we'll dive into a real world example where we have worked with various different firms over time. I mean, really, this is a pretty global example in this case where everyone is now leaning on video. I mean, we're doing a video call right now to do this. I think many meetings are, as people are kind of hybrid, all remote, transitioning back to offices, things like that. It kind of increasingly, has made this complicated network setup of how people need these real-time applications to communicate with each other. So if a firm relies heavily on something like voice and video conferencing and they're having a big important meeting, some sort of quarterly review or something like that, and they experience a significant slowdown, it's going to impact the quality of that meeting. I mean, maybe you had a great successful quarter and you can't wait to report about that, but you get into the call and all of a sudden it's dropping and it's full of holes and it just leaves a bad impression and really impacts that user's experience. And then they're going to pivot to the network and go, why are these tools not working for us when we need them to? So, that really just gives you an example of why knowing these things in real time is going to be better than waiting until a user has felt the impact of it.
Yeah, and just to sort of, put a period on that, I think you're spot on. And there's a use case that comes to mind with a financial firm, pretty bread and butter, but just really highlights what, we're capable of doing. Facing some serious issues with video calls, drop connections was really frustrating to some of their higher value clients. And our platform with its analytics capability helped uncover the root cause, right? Back to root cause analysis again of these slowdowns. So, through a combination of traffic pattern analysis, we identified a surge in network traffic caused by a single department. uploading large financial data sets to the cloud and overwhelming bandwidth during critical business hours, right? And with our help, they were able to adjust when and how that was done. And it's just a good example of why it's important, even as we automate more and more things, that we maintain an understanding of how the traffic actually flows across our network and when and how it does so.
Yeah, right. So again, unifying performance metrics, QoS labels, DSCP, everything that actually occurred in the network traffic that was underneath that user experience. Again, having it all aggregated in one place, having one unified plane run analytics against all of it is how you're going to be able to identify those things, and then hopefully identify those things in a time frame where, again, it prevents that inevitable user impact scenario where all of a sudden, performance actually appears degraded.
So I just mentioned a financial use case, and I think I want to just take a moment and walk through some of the key benefits and outcomes of deploying us in this instance to address the root cause, which was, with rapid identification, comes rapid resolution. Normal operations were restored within minutes because less time was spent having to hunt down where and what was going on. And then, Adam, why don't you walk us briefly through what some of the key benefits are they achieved?
Yeah, for sure. So again, it's really this main point of the downtime, or in the case of a real-time application, section of degraded performance where all of a sudden jitter spikes and you can't hear people or you can't see people. That immediately pivots into continuity of business operations. If that is a mission critical call, I mean, if you're a video provider, as an example, and the customer's having those types of problems, now it's become kind of unacceptable in the delivery of the actual product you have. That's obviously going to improve user experience as you don't run into problems where it appears the network can't actually handle what you're trying to do on it. And then ultimately let you work in a space where as these things are happening, you're fixing them. So it doesn't need to correlate directly again to a felt user experience. It can be a matter of it sees these things occurring. The analytics have detected that this is an anomalous event, forwards it to someone that can take a look at it, and then they can go in and again remediate the situation or find that large file transfer when it's happening, not during a business critical time, get it fixed then, and then all of a sudden, it, again, improves that end user experience when the time comes for the network to really have their back.
Yeah, and I mean beyond sort of the immediate fix we were just discussing, I think they put them in a position that they were able to implement much more proactive network optimization strategies based on some of the insights gleaned from Scrutinizer, right? And ensuring long-term bandwidth efficiency and planning for future growth.
Yeah, again, just staying ahead of it and having the system watch all the time. I always joke with people, it's like the system doesn't think about what it's doing this weekend. It doesn't think about what's for lunch. It doesn't think about the commute home after work. It just focuses on the network 100% of the time, including during kind of the dark times on the network when maybe otherwise there's less eyes on it. So for another real world scenario, if we think in the healthcare industry, a leading health insurance company was experiencing periodic slowdowns in critical applications, such as their claims processing and their customer support portals, due to just a growing remote workforce and kind of a differential in where people are using their network.
Yeah, I mean, I think this is a good use case for where historical trend analysis was really valuable. Using our capability, yeah, first of all, always important to know we store data as long as our customers want to, right? And then with our new AI-driven analytics capability, we're able to forecast and identify two things. So one, we identified a 20% year-over-year increase in remote access traffic. And then two, using our AI-driven analytics platform, we were able to forecast an additional 25% growth over the next year, which allowed the healthcare company's IT team to prepare for that growth much more proactively.
Yeah, so the forecasting engine was a project that I thought was very important to get into the platform, and we did quite a few years ago now, so it's had quite a bit of time to mature. And really what it allows is, on the dashboard page earlier, we were talking about input data sources being very portable. In the case of our dashboards, they make visuals. In the case of API, they can power really any other objective you have going on. What our forecasting engine does is it takes those same data sources and can project them forward into the future per line item in the report. So it doesn't necessarily get to a situation where the usage of multiple applications is just being lumped together and then you're making a forecast that way. It actually looks at each individual component separately, forecast those together, so you can see like a real dynamic projection of what all of those things would be together. So that way, if the trends are, one application that's trending down in usage, one that's trending up, one that's very seasonal, each of them preserve their own usage patterns in that forecast to give a better overall picture as it comes out of the other side. Another issue with this type of stuff is, again, the volume of flow data is extremely high. And doing forecasts on extremely high granularity data over long time frames is computationally a very difficult process. So we've implemented some pretty interesting techniques that will allow very high granular data to be projected out into the future. So it's something that typically you'll see on something like an SNMP based tool that's looking at just counters that don't know anything about the context of what they're doing. So this is really taking that idea that people might be used to and bringing out and actually applying the context of what the traffic is doing. So that is the major difference here, and that's what enables a use case like this, is where we're not just looking at usage at the edge, going out to some, maybe known IP that's part of AWS or something like that, where you expect this traffic to be going, but you maybe get some loss of visibility as to actually what target it's hitting within that. This applies forecasting at the context layer with all of the information that's available in the flow. So it seems very simple at first, but it becomes quite powerful when you kind of get a chance to use it in juxtaposition of the traditional like SNMP based forecasting paradigm.
Really, it comes down to that they were successfully able to prevent potential network outages, right, by scaling their resources before performance bottlenecks could even impact operations.
Yeah. So again, just getting ahead of it, the whole banner of this talk in the first place is real-time action, moving the detection of the problem to the instant it occurs versus moving it back into when it's felt. And in the case of forecasting, that now we're talking huge time frames where it's like, let's find out right now what 3 months from now looks like so we can plan accordingly. And the biggest benefit is now it's supported with data. You can bring the historical data that's used for these forecasts as well as the forecast result to actually justify those decisions moving forward, because it can be pretty expensive when you start making changes at the edge. So the more evidence you have to support that decision, kind of the safer it's going to be, more likely to get approved for that expense to do it. Really, the main idea is moving all of the decision making up right to when it's observed on the network. And then again, in this case, projecting that forward into kind of the hypothetical to be able to make some decisions long before they happen, as opposed to just kind of as close to when they happen as possible.
Yeah, and I think it's important to note that we did it all. We did all of this. We should have ensured that the network remained ready to meet stringent healthcare data regulations without performance degradation.
Yeah. Yeah, that's the best part of using your existing infrastructure as the data source is nothing really needs to be changed. We don't need to introduce new things onto the network in order to get this visibility. We can pull it out as it's structured now, and then you can pretty easily, kind of segment things and look at the context of that particular network segment without having to change topology or change really anything about its structure in the process of getting this insight. Sometimes it can be pretty cumbersome to enable insight into the network in a way where you start to kind of consider the cost benefit analysis of like, is our workflow that much better after doing all this effort to install some crazy thing that will watch the network? This just takes advantage of what's already there. So for a final example from higher education, the IT department at a college noticed a gradual rise in network latency across their academic buildings as students streamed education content. A lot of times now people just like watch the lectures instead of actually going, but all of a sudden now, if you're a big college, you've got thousands of people streaming video on kind of tight network segment.
Yeah, and I think this is, look, another great example, right? Because using our trend analysis, they detected consistent spikes in latency well before major exam dates, right? Highlighting the need for more proactive bandwidth allocation. And then with this knowledge, this insight, the IT team could then dynamically reallocate bandwidth to prioritize academic platforms over non-critical traffic.
Yeah, so whether it's bandwidth or another component of monitoring latency, it's again one of those things where if the network can feel it first, you will still have time to actually make a change to, kind of ensure the user's experience is going to be felt. For latency metrics, we're looking at TCP latency metrics as well as jitter on RTP, UTP delivered real-time traffic. So in the case of something with high an interactive situation like the call we're on now, there is still some opportunity to tune jitter buffers and things like that. And by monitoring the network, we can even run so we talked about forecast in the last example for capacity. That again can be applied to any of the reporting objects. So if you are getting TCP latency or UDP jitter from a device or our flow pros, you can actually bound the future projection of that stuff in a forecast and get an idea, because it's pretty stationary data. It actually forecasts very well. So as you move into the future, you can get an idea of like what your worst case scenario jitters would be given the data you've seen so far. And then you can go out and retune jitter buffers in the applications to actually account for the fact that you know this is the worst case that's likely to occur on the network and make the application ready for that. So it actually knows when it's filling its incoming buffer for data, it can expect these various conditions on the network to be happening. So again, it just reduces the times that users are going to feel the impact of that application or network-based application failure by just detecting it as soon as it's happening, right? Like the sensors that see jitter feel it the second this is monitored in milliseconds, and it's looking at the inner arrival time of packets. So it's going to know in like sub-second, it's going to know that these things are starting to occur. Whereas, a user, by the time they feel it, it's probably been a minute before they realize, okay, this is really happening. And then they probably finish their call most of the time in a bad state and then report it that it happened, right? So it's like the whole damage is already done in that case.
Yeah.
So moving into proactive kind of real-time analytics, it allows you to watch those things much faster than human perception time, and it gives some window for remediation before it actually impacts the user on the end.
Yeah. Yeah, no, that's really good. I mean, I think it's such a valuable use case, right? Just because we're talking about another one I want to point out is with the growing trend of esports, right? Particular universities forming these teams. I'm seeing more and more of our higher ed customers leveraging us to help ensure performance there. But I think which of these use cases we're talking about, I think either way, the outstanding results, or I should say like the critically important results they deliver are the same, right? If you're gaming, you need as low latency as possible. And if you're, zooming in during exam time, you need as low latency as possible. And I think early detection of these spikes help prevent disruptions, ensuring students could complete exams without connectivity issues, or, if they're playing League of Legends or Counter-Strike, right? Hopefully take home the cup, so to speak.
Yeah. Yeah. So esports is a very fun example of real-time applications becoming more critical for people, but you can extrapolate that across the board. People might be running like drone swarms that are all inter-networked and then communicate back to a base station, and that base station relays some information back to a general control center. That's going to be another case where application latency is going to be very important to monitor, and all sorts of industrial control system type of things where you have machines or production lines that are pretty tightly inter-networked. Having insight into any particular network segment, having a performance problem there can get ahead of a huge cascade of issues if you can just kind of terminate that as soon as it's detected, as opposed to letting damage happen first. Again, with the very lighthearted case is that you're on a video call and it's just
Right.
bad quality talking, right? But much more mission critical applications, databases, things like that are going to start to really cause a slowdown in the overall operation of business. There's really no reason in this paradigm to wait for the damage to be done before you can begin remediation.
Yeah, I mean, look, it really comes down to just ensuring a high quality user experience, right? And with everything going digital, and even at university, everything becoming more digital, it really becomes critical that you have a reputation for digital excellence, right? And I think in this instance, we help do that among both students and faculty alike.
Yeah. So awesome. So we'll take a look at the Q&A now if anything came up as we're talking, or if there's even just a point you want to make on the topic that we can kind of read aloud to everyone. Now's an opportunity to enter those questions.
Take a quick look here. All right, we got a couple. Pretty straightforward. Let's start with this one. You mentioned customization. How easy is it to tailor dashboards and reports to fit our specific needs? Do we need a dedicated IT team for that? No, you don't. It's pretty straightforward, but I'll let Adam take that.
Yeah, so I touched on it a couple times as we went through. All of the dashboard gadgets or API calls that you want to make can all be built from our reporting wizard that walks you through step by step for selecting input sources, selecting filters, selecting timeframes, dynamic timeframes if you want that to always, in the dashboard case, that's always a dynamic time frame for the most part, right? Where I want to see the last 24 hours, last 7 days, last hour, last 15 minutes, or static views. But again, more often than not, if you're making a gadget, it's probably gonna be a dynamic view. But our reporting wizard takes you step by step, click by click through getting to the endpoint data you want, allows you to apply filtration against parameters that are both in the report and parameters that maybe aren't directly in the report, but are on the network observability records. And then ultimately, you can just freeze that report at any point in time, and its definition will carry over to power those other gadgets. So you can use kind of a simple walkthrough to get to the end data that you want to see. And then once you're happy with the result, you can freeze it, kind of choose your visualization style for it, just things like that. Freeze it and then make it into a dashboard gadget that can be used. And then those dashboard views as well are very customizable in the sense you can resize things and move them around. So you can really get a workflow going where the data you expect to see is going to be where you expect to see it,
Yeah.
and you can get kind of comfortable with that loop.
Yeah, what I usually tell customers is if as long as it's a data point that is provided in your flow, we can most likely build a dashboard around it, right?
Yeah.
Yeah. All right, we got a question here. Do you have visibility into hybrid cloud environments, and do you have a way to replicate data to multiple sources?
Yeah, so we do have on the replication side, we do have a product called the Replicator that is a IP fix and UDP basically forwarder. You can put it in the network and redirect traffic based on an input port to an output port and a list of collectors. So that can be to the Plixer platform. That can be really to anywhere you want to send that data. That's been a very powerful tool over time for people for UDP direction.
Yeah.
On the other point of multi-input environments, we have bespoke collection binaries that can pull things out of AWS, Azure, all the major cloud environments. Most vendors have direct integration as well, where they can output IPFix, but effectively any network segment or device that is capable of exporting IPFix can immediately integrate with us or NetFlow or whatever that vendor might be calling their specific version of IPFix. And then ultimately we have the part of the Plixer platform is a product called the Flow Pro that does both network intrusion detection as well as latency and jitter measures for application performance. So those can be dropped in anywhere you can get a mirror or span so it can watch the traffic. And that ultimately kind of breaks that one constraint of needing visibility in places where maybe the devices can't output it. So that solves that corner case. But otherwise, that's really the whole point of the platform is integrating data from all of these different data sources in the same place. So hybrid, all on-prem, all in cloud. In each of those cases, you basically get the same experience within the product.
Yeah. Yep. Good question. Thank you. We got one more here, which is we have a small IT team. How easy is it to start using Plixer, and what kind of support or training is available? I'm gonna, if you want to add to it, Adam, feel free to, but I'm gonna take this one. So I would say you get very comprehensive support. One of the things that makes Plixer great and what sets us apart from other software vendors is our dedicated customer success team provides ongoing support and enablement at no additional cost. And look, I've been here for 10 years, so I can very confidently tell you that we have an industry-leading support team, very responsive, and we constantly get high marks. So if you are interested, regardless of what your IT team size is, reach out. Feel free to reach out to me directly. It's my first name, period, last name at plixer.com. I'm happy to get you in touch with your sales rep.
Yeah. And I really can't underestimate our support team works with hundreds, if not thousands of environments, in getting visibility going. So they've seen almost every configuration of vendors and use cases to get in place. And really setting this up in the first place is kind of a one-off thing, right? Some of the configurations are a little weird in various devices for getting the IPFix data exporting, and we just have done it before. So our team is more than happy to jump on with you, get everything configured and set up, and then you never really have to touch it again anyway. So investing a ton of time and resources into kind of learning how to get it configured kind of ends up just being redundant because we have people that can just get it going for you, and then you never have to touch it again. As you add new network segments or new devices, the team is more than happy to reach out, show you how to do it with you.
Yeah.
But again, ultimately, once the visibility is set up, you can really kind of forget about where the actual maintenance of the data sources themselves, and then just stay kind of on mission.
Yeah, that's right. Just core to edge to cloud visibility. Okay, I think.
All right,
Do you have
awesome.
any other ones? No, I think that's it.
So thank you everyone so much for joining us today. This is, I think, a really exciting technology that it just takes some appreciation for what the problem is that's being solved, and that is your network it does a lot. There are hundreds of millions of events happening, and really no one individual or team of people can actually go through all of that stuff. So at some point in the workflow, something needs to aggregate that huge volume of events down to something that's actionable. And that's what our whole platform is based around, is bringing the enormous amount of network events down to things that are an actual reasonable amount of actions to take to keep the network in the healthiest state that it can be. So again, thank you for joining us today. Thank you, Niels, for doing this with me,
Yeah, of course.
and hope everyone has a great day.
Thank you guys.